Yeah. Does this represent a function?
Not yet.
Well, a function can be, that's the other thing. Nowhere in this function did I say that it had to be a continuous graph of any sort. So individual data points can also be a function. You don't have to necessarily connect the dots, in other words. But I'm going to go ahead and draw this in a minute. But before I draw this, does anyone have a guess on whether this is a function or not? No? Laura, do you have another question?
Yeah. I forget which one goes first. Is it the x?
Great. You know what? I should be reviewing that as well. Each of these is an x, y coordinate pair. These x always goes first. Yes, Ryan? Why do you say it's not a function?
Because obviously it goes from second quadrant into the first and then back into the second quadrant.
Actually, if we were connecting the dots, that would totally be accurate. But these dots could be unconnected. So I'm not going to say whether it is a function or not. You're right, because you're thinking that because the x's go negative and then positive again, that this thing must look something like this, right? And that would fail the vertical line test. That is excellent logic, except these dots don't have to be connected.
What do you mean
And I can give them to you out of order. It means I can just, you can graph a relationship that's just made up of just dots. I don't have to connect them like Rodney was thinking. Your logic was great, though.
So you could just pull one of those out, and can you do them out of order? Is that what you're saying?
Now I'm going to go ahead and graph them, but first I want to see if Philip has an idea.
It's not a function because there are two -3's in the x's. Like there's.
And is there the same y for each of those -3?
No.
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 So.
Okay.
Which means it can be a
But
function.
it don't hit
Okay. Philip's got it actually.
No.
For x equals -3, here I say y equals 5. Here for x equals -3, I say y equals 6.
So it's not a function?
Yep, same input, -3 both case, two different outputs. Okay, now if I just graph these points, I realize I made that a little harder by not giving you the visual first, but I wanted to see if anybody was going to catch it by the definition. Nicely done, sir. So now that's 1, 2, 3, 0, 1, 2, 3, 4. And here's what happens if you graph this. Got my y's here, got my negative y's down here, got my x's here, got my negative x's here. Once again, I hope this is a review, but please ask me like Laura did if there's any part of this that seems totally new or exciting. These are quadrants 1, 2, 3, and 4. You don't have to label all these every time you graph something, but for now I'm going to. 1, 2, 3, 4, 5, 6. Okay, first we have the point -3, 5. That should be there. Does that look like I graphed it correctly? Maybe a little high?
Oh, it's fine.
That's fine? Good. Okay, now -1, 2. Is that about right?
Yeah.
Okay, 0, 4. Don't go anywhere left or right. Go up here to 0, 4. 1, 8. I did not put enough room on my graph. I should think these things through in advance. But
That'd be helpful.
1, 8 is there. I'm going to skip -3, 6 for a second.
You have 9,5.
Why are you skipping it?
Because that's the one that makes it not a function. Okay? At this point, even if all we see are these dots, this is a function. Because if I draw a vertical line through one dot, it doesn't hit another one. Okay? Functions can consist of just data. It's kind of funny. That's the point we kind of make for this chapter, and then, I'll be honest, we won't talk about that again the rest of the year. All we'll deal with are functions that are equations and graphs where you connect the dots, like Rodney was thinking. However, I put in one other point over there. I put in the point -3, 6.
Oh, I see what you mean.
At this point, we now have a failure of the vertical line test. We have 2 points in the same data set that are on top of each other. This means if I were measuring a plant growth, then on day -3, whatever that means, the plant was simultaneously 5 and 6 inches tall or something. That can't happen in an experiment, or if it does, you've screwed up somewhere. So that's why this is no longer a function. Once I put in this other point, it fails the vertical line test. So we can describe functions in terms of data points or graphs. Other things we can do is I can show you some graphs like, okay, that's a continuation of this example over here. This is a different example. I'll do it in a different color.
But I think it in the form like of slope intercept.
Lines work. Well, yeah, here's, I'm just going to do this visually. Here's a line. Is that a function?
Yes. Because
Mimi says yes with confidence.
Yeah.
Yes, it is. Because anywhere I draw a vertical line, it will only hit this line once. Because if I put any value in for x, it will only correspond to one value for y. One input, one output is true everywhere on this line. Okay? The simplest way for most kids is to just picture a vertical line will only hit it once everywhere it exists. Everywhere you can imagine it existing. It's not a particularly difficult equation to graph a circle.
Not a function.
And we'll go into how to graph circles later this year. Is a circle a function? No. Oh, by the way, I should write that. Yes.
Well, it's
No.
kind of obvious too.
Yeah, it really fails the vertical line test. You hit it, it hits it, it goes from a vertical line doesn't hit it at all, to a vertical line hits it once right here on this edge, to the vertical line hitting it twice everywhere else it exists except for these two edges. I put in one input as an x, I get two outputs, one above, one below. That is completely not a function. There's a type of graph you're going to learn about probably not until March or April. It's called a sine wave. I'm just going to show you that it looks like this. Yeah, put it down as an example. And all I'll tell you right now is it looks like this, and that the pattern doesn't change for its entire existence. It goes up and down like that.
So it's not a function.
Is this a function?
Yeah, because they only cross their once.
Yeah, vertical line test. Anywhere you can imagine. I just told you it doesn't change forever and ever.
Did we do this in Algebra?
I hope so. I hope this is mostly review.
No.
This, I hope not. I'd be a little surprised if you got the sine wave in Algebra 1.
How? Wait, if
I
you do
have.
it horizontal.
That wasn't in your Algebra 1 class, but this, yeah.
You wrote the wrong thing.
Yeah.
In the hospital, when they do that thing. Is that
That's based on a sine wave, yes.
Then why
Yes.
did you say no if it was a vertical?
Oh, haha. Yes. Yes, 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 yes. It is a function. Yes, thank you, Nimi. I can also graph x equals sine y if I want. This is a little less common. Like Micah just pointed out, hospital EKGs and other graphs, the things you see on monitors in hospitals, are based on this. We're so used to seeing time this way, you won't usually see a hospital graph
See,
that
that's
does
not
that.
vertical.
Okay, now is this a function?
No,
No.
because if you go down, it touches it more than
Yeah.
once.
Actually, you can imagine a vertical line hitting this literally an infinite number of times since it goes up and down forever.